Hi, via Group 13. I'm Wen Caihong. Our topic is method validation for melamine quantification based on calculus technical criteria. We will interpret the topic through following 5 parts as shown in PPT. First part is the background. We will talk about why we have to do the melamine quantification and which method to use. The chemical structure of melamine is as shown here, where 67% of the total mass is contributed by nitrogen. Due to the properties of its derivatives, such as durable thermal setting, melamine is widely used as industrial material for manufacturing various products. However, some manufacturers add melamine into the protein products to increase protein content, which are usually determined by the Cadridel method since 2007. This could result in reproductive damage, causing bladder or kidney stones or even bladder cancer. Therefore, tolerable daily intake and maximum residue limits were set by countries and the international agency. In Hong Kong, follow the regulations of United Nations. Melamine limitation is 1 microgram per kilogram in milk and any food for children under 36 months or pregnant or lactating women, but 2 microgram per kilogram for other foods. According to the reference, liquid chromatography combining triple, quadruple, tandem mass spectrometry is applied for melamine quantification. This is the non-standard method. Thus, it should be validated and authorized before application in the laboratory. As we know, liquid chromatography is used to separate mixtures in a liquid mobile phase using a solid stationary phase. Then the mixture separated containing melamine is introduced into the tandem mass. By selecting the parent ion and the daughter ion specific to melamine, the melamine in food could be qualified and quantified. Before injecting into LC tandem MS, extraction is required, and for quantification, internal standards should be added. Melamine will be extracted into 50-50 acetylnitrile water solvent and cleaned up with mixed mode cation exchange solid phase extraction after centrifugation. Next part is about cleaning. According to the Hochfleisch, as this method is a non-standard method, it requires 4 validation, which means we need to validate all the 8 performance characteristics. Also, for the personnel who will do the testing, there are some requirements. For example, to manipulate LC tandem MS, staff should have complete a post-secondary curriculum in chemistry. In addition, to get valid result, environmental conditions should be tested and controlled in an acceptable range, such as temperature. A most important part in the method validation in this case is that we should validate all these performance characteristics and that they could meet the requirement. First one is the selectivity of LC tandem MS. Selectivity is the ability to separate analyte from the sample. According to the Hochfleisch, we need to use reference materials to confirm the selectivity of the LC tandem MS, or we could use test samples containing various suspected interferences in the presence of the melamine. In LC tandem MS with SRM, only the mixture containing melamine could be injected into tandem MS, and by selective reaction method, we could select a specific parent and daughter ion for melamine. Thus, this method has very high selectivity for melamine quantification. According to the reference article, if we use UPLC, the selectivity may reach even higher level.
Okay, hello everyone, this is Zhitong. Before the LOD and ALQ, let's talk about the food metrics. In Hochfleisch's criteria for the general food analysis, a satisfactory validation should be operated for at least 5 food metrics with at least 3 kinds of food for each matrix. So we select the 15 kinds of food from the reported melamine detected sample matrix as shown in this table. The next is to estimate the ALD and ALQ. There are 4 steps. First, to operate replicate measurements of blank samples for 10 times. Then, calculate the standard deviations of these results. Next, to estimate the LOD by 3 times of the standard deviation and LOQ by 10 times of that. And finally, to verify this estimate LOD and LQ by the rejections. On this picture, we can see that the FDA measured the signal to noise ratio is much larger than 10. The ALQ must be able to quantify the regulation limits of the melamine according to the Hong Kong regulations. As Cai Hong referred, the regulation limits are 1 ppm and 2.5 ppm. And the ALQ in the FDA method is 25 ppb for tissue and liquid formula, and 200 ppb for the dry infant formula powder, which means they are satisfied the regulation limits. And next is the working range. The working range should cover the regulation limits, but the unit for these limits is the mass ratio, such as ppb and ppm. The results are shown in the ALC tender mass are in the units of the concentration. So the first step of the estimation of the working range is to convert the mass ratio into concentration level. From the sample pretreatment, the dilution factor is calculated as 40. Then the convert result should be calculated and shown in this table. The minimal level is 25 nanogram per milliliter, and the maximum one is 312.5 nanogram per milliliter. Therefore, a 500 calibration point should be added. To verify this estimation, first, prepare 6 working standards at different concentrations, then operate the ALC tender mass analysis by random injection. And next, to draw the calibration curve and calculate the calibration equation and R value. And finally, draw the residue with the versus the conversation graph. The residue versus conversation graph should like a random sample from a normal distribution with the 0 mean. And this picture shows the calibration curve and the R value. And finally, in my part is the sensitivity, which is the slope of the calibration curve. That's all. Thank you.
A practical determination of bias relies on comparison of the mean of the results from the candidate method with a suitable reference value. 3 general approaches are available. First, analysis of reference material. Second, the recovery experiments using spiked samples. And third, comparison with results obtained with another method. In these methods, no reference materials is available, and the spiked recovery study is used. Measure matrix blanks or test samples and spiked with the analysis of interest over a range of concentrations. In default of complete coverage, it may be suitable to estimate recovery at some critical levels of analyzed concentration. For example, at the regulatory limit. I classified 15 metrics into 2 types according to 2 regulation limits, and 3 steps to calculate the relative spike recovery at the various concentrations. According to Hawkins, applicable range of recovery are as follows. In this method, recovery of 18 to 110% is used. Precision is a measure of how close results are to one another. It's usually expressed by statistical parameters which describe the spread of results, typically the standard deviation or relative standard deviation, calculated from results obtained by carrying out replicate measurements on a suitable material under specific conditions. Here I designed 3 experiments to separate the measure repeatability, intermediate precision, and reproducibility, and spiked sample blanks at various concentrations across working range. Send us the bias part. Thank you. That's my part.
My name is Xiao Hao. Then I will talk about the determination of measurement uncertainty in this method validation of melamine. Measurement uncertainty is a range that could reasonably be attributed to measurement result. To determine measurement uncertainty require a few steps. First is to identify the information or data that contain uncertainty, which require us to do a cause and effect diagram. In the quantification of melamine, there are 5 kinds of source of uncertainty, which are the volume of sample, mass of sample, recovery, calibration curve, and precision. Once we get all 5 standard uncertainty, we can use this formula to calculate the combined standard uncertainty and the expanded uncertainty, which is the MU. How to determine this standard uncertainty? For the volume, we can use the uncertainty given by the flask, and for the mass, the uncertainty is plus or minus 1 in the least significant digit. To minimize the uncertainty, we can use a flask with more precise reading or a more precise digital scale that can provide more digits. As for the standard uncertainty of recovery, precision, and calibration, these are mainly generated by the LCMS machine, therefore can be obtained in the machine's specification. Once the measurement uncertainty is calculated, it will be compared with the method limit of quantification of melamine, which is about 25 milligrams per kilogram for tissue and liquid formula, and 200 milligram for dry infant formula product to determine whether it's a suitable method. The robustness is the capacity of a method to remain unaffected by small variation in method parameters. This is a measure of reliability of the method. To determine the robustness, we first need to identify variables which affect on method performance, and then purposely vary the method parameter over a known range and determine the effect on the result. In the experiment, we identify 3 variables, which is the concentration of formic acid, the time of bending with polytron, and the time of shaking to distort the melamine sample. Experiment will be repeated using variables mentioned above, and then the difference between those experiment value and the true value will be used in the evaluation of the robustness. To get a good robustness, the dissolution of solid can be monitored by naked eye to determine the effect of shaking and bending. And for the concentration of formic acids, ion selective electrode should be a proper method to aid the analysis. And this will be an example of result to evaluate the robustness. So since the method is very highly selective, show good linearity with good recovery and so on, we could use a conclusion that LCMS could be validated for melamine quantification. And these are the reference, and thank you for listening.